All right, welcome, ladies and gentlemen, to Open Live Q&A. My name is Mr. McLogan, and happy to have it join another live stream. This is week number 135. I do apologize for some of my little issues. I thought my camera was all set up, and then I went to go and take the kind of overlay off, and it was not giving me actually any video feed. So I was like, that's not good. Let me go ahead and fix that. So that's exactly what I had to do. I do apologize for that. I know it's kind of a little frustrating, it's a little annoying, but hopefully you guys are able to get a notification and get back on the stream. So so a new school year is coming upon us, and I know there's going to be hopefully some questions as you guys are getting ready and prepared. And it's definitely a very exciting time. At least to me, I always love like August and like the getting back to school, and because it's always like a kind of a little fresh beginning. So that is kind of the season that we're in, and so I'm happy to kind of answer questions. If you guys do have any like math questions, feel free to go to brianmclogan.com/Q&A. If you have any just kind of generic questions, feel free to go ahead and add them in the chat. So Angel, I'm having the SAT this month. Wish me luck. Well, I wish you the very best of luck. And what time is it for me? It is 9:07 p.m. for me tonight. So that is where I go live each and every Sunday night at 9 p.m. So this is, if you guys do have questions, throughout the year, I do plan on doing this live stream throughout the year, continuing on Sunday night. So this is a week number 135, meaning I've been going live for 135 weeks straight. So good old fun. And I wonder actually, the other stream went down. So hopefully anybody that was on the last stream will head over. So please explain the remainder theorem. I can definitely go ahead and try to do that. If you want me to kind of remember the questions, though, it's probably best to go to brianmclogan.com/Q&A. Hold on, send my question. Could I get help with it? I'll try to do my best. Not every single question, guys, am I going to be able to answer. I think hopefully you guys can understand that, just doing a whole bunch of questions is not always going to be possible. And so that's why I have you guys at least go ahead and submit your questions so I can kind of go ahead and review them and just go and take a look. But I did want to also let you guys know that just a reminder, I am going to be doing a giveaway as well for some free tutoring. So before I get into any of the math, I do want to kind of give away a free tutoring session with me. So there's really nothing, no kind of catch or anything like that. I really just want to kind of help out some students, especially those of you that are following on my channel. So if that's something you are interested in, then stay on, and I'll let you know about that coming up in, I don't know, maybe sometime kind of midstream before I get into the math content. Before I start transitioning over to helping you guys with the math, we'll do a little giveaway. And yeah, it's just whatever kind of works for our schedules to kind of get that done. So I'm kind of excited. I did that a little bit last year, and my schedule just kind of got so busy that I wasn't able to do it. But I think it's definitely something that I'm going to, something benefit. Obviously the students, can benefit, but also it just kind of helps me kind of stay fresh and kind of like on point. Oh, my video was downloaded finally. So I have my video. I was waiting for that. Cool. Okay. I'll upload that later. So but yeah, for me to kind of like stay on point a little bit with my math from on there. I will try to get to your questions. I'll try to get to as many questions as I possibly can. Nope, I am not a gamer. I used to go, used to play, but that was a long time ago from on that. So, what else am I looking for? Okay, not that. There we go. I got to open up some of my apps did not have. Ready to go. Okay, so let's go ahead and move that over there. Move that from there. And then I just got to find my Open Live Q&A from on that. So, do you watch JoJo? No, I did not. All right, let's go ahead and check in some of the questions. Again, if you guys do have questions, go to brianmclogan.com/Q&A. And then I will try to do my best here to go ahead and answer them. But before I get into any of those questions, though, I do want to make sure that I have. What mic am I using? I'm using a Rode mic. I do not have any of the links, but I am going to do a kind of behind the scenes video kind of coming up. And I will have some mics coming up from there. I also do use a Blue Yeti quite a bit as well. And I've always liked that one. The only reason why I transitioned out of this is I had to use this like boom mic, because so many times I'm like, talking right here. So when I always had the Blue Yeti, I was always knocking it, and it was always like right in my way, and it just kind of got annoying from that card. Do you make another? Yeah. No, I don't have any really recommendations for that. I think, just do the best you can possibly do. I mean, I'm sure there's tons of amazing websites. I think that when you're studying for the SAT, ACT, like just do as many questions as you possibly can do. So I know that I'm sure there's going to be plenty of websites, and YouTube channels that have tons of examples. My channel is not one that really kind of focuses on that. So, but I'm sure there's tons of resources out there, and just try to practice as much as you possibly can for that. And hey, Avery, how are you? Good to have you on. You've been such a big help with my math. Well, awesome. So happy to be able to help you out. Up, down. All right, let's go ahead and I don't even know if this is the right one. I'm like looking at my document. Nope, that's not the right one. Let's go ahead and find. Man, I can't believe this has been 3 years. That's so crazy. Okay. What type of math do you learn in middle school? Unfortunately, it's been a really, really long time. I only taught middle school actually as an in-service teacher. So I actually never taught middle school as like an actual teacher. I don't know. When I was only as like what do you call it? Like a pre-teacher, service teacher, student teacher. Yeah. When I was a student teacher, I taught middle school, but that was it. And I barely remember like when I was there. So unfortunately, I don't have a great access for you, but I'm sure if you look at like 7th grade math, 8th grade math, like you can find some syllabus of, of some curriculum in books, and to kind of get an idea of the type of math you'd be looking at. Any advice for high school graduates looking into becoming an applied math major? Things to consider. Well, I don't really do it I don't know. I mean, I don't really have a lot of advice for as far as the, applied math, math major, because that's not something that I went into. So unfortunately, I'm not sure if I really have any great advice that I can go into. I mean, besides really just kind of like creating a good relationship with your guidance counselor and the math teachers that are in that department, to try to figure out what exactly you want to be doing with those courses and help you along. So I think just kind of building that kind of relationship would be my best piece of advice, because obviously like things are going to change, as you go through college. You take different classes. Some classes you're going to love, some classes you're not going to love. And so I think just, kind of keeping an open mind, try making sure that you don't just decide like one route or not is going to be, right for you at any given time, but, kind of make sure you also keep an open dialogue and looking at exploring a lot of options. That'd be, I guess, my best advice. Hello, quick question. I'm taking an online course on algebra this summer and I'm almost done. Awesome. I hope to take the CBE. What advice do you have? Wish you the best. I mean, I would just, my best advice as far as, as you're preparing for the, kind of the CBE is go back through all the information, copy down a lot of stuff on like cheat sheets and kind of study from there, review your tests, review those quizzes. If you have copies of them, I know it's online. So, kind of review the things that you got wrong. But yeah, try not to cram. I think for the last 2 days, you should just be doing a light review, as you're going up from there. But I think you should definitely if you have like a week or two, like start trying to study like often and start studying like now from on that. Is there a free advanced I'm sure there is. I'm not sure. I don't have any advanced functions courses. I think advanced functions, I think that's the same thing as like the pre-calculus. I'm assuming you're out in Canada, because I remember when I would always talk to people about my pre-calculus course, they're always looking for advanced functions. I do not have an advanced functions, a free version of like pre-calculus or advanced functions. I mean, obviously like the reason why I sell my pre-calculus course and don't give away for free is like, I mean, all the videos are not online or on YouTube, but I have a ton, I have all the content you could possibly need on YouTube. It just might take you a lot longer to find, to go through everything, but it's all there. Like you don't need to pay for any content. And I would say that'd be the same for like anything. The purpose of the course is to get you to kind of point A to point B in a much quicker and faster and easier way in a streamlined approach. And that's what I kind of provide for my pre-calculus course. And so, yeah, so, I mean, I'm sure there's some different, some free versions of courses, I'm sure out there. There's even some videos, and I'm even going to be posting a video, that's going to be like basically cover all the material you need. It just depends on, how you want to be taught or and how you're going to be able to make the most of that information. I mean, yeah, I would definitely not want to just rely on converting the radians to degrees. Yeah, I think, knowing your radians is going to be very helpful. And I'm not really sure if there's like a specific thing that you like need to know about radians. I think just being familiar and being able to use them and apply them and understand them is going to be very helpful. Search degrees and how it's part of a circle. Yeah. I mean, I guess we can just keep it as bland from that and say, yeah, well, let's just keep it from there. You'll be good. Are there, you're very welcome. I don't know. Did I move that? Oh, okay. I filled in the form 2 times and used the first one is a mistake. Okay. The second one was what I was trying to ask. All right. I will try it out. Okay. So thanks. You are very welcome. That is not getting on. There we go. Okay, cool. All right, let's go ahead and do a giveaway. So what I'm going to do is I did my giveaway last time and it didn't really work out the way I wanted to because I was like, oh, let's do it on my last video. But I'm like, a lot of people comment on a random video of mine and they might not want in the tutoring or anything else. So what I would say is if you want to go to last week's live stream, which I will actually put a link in. Actually, let's see. Yeah. If you guys want to go ahead and I'll put a link in from there because I was gonna. If you guys want to go to last week's live stream and go ahead and just put in a comment, any comments, you can put in. I think last year I did like a lot of math help, or just whatever comment. If you want to say thank you so much, whatever you guys have going on, that is perfectly fine. Or hey, I'm looking for tutoring. Whatever you want to do works definitely for me. What I'm going to do is I'm just going to take a comment from last week's live stream. So if you guys have anything on that. So what I'm going to do is I'm just going to go and pull that link from last week's, not the live stream that I botched, but week number 134. So if you guys just want to post a comment on there, we'll go ahead and do a quick little giveaway for free tutoring. And then yeah, we'll get on to actually doing some math. All right, so let's go and ready to get to back to school. I have questions, ask away. There we go. Yeah, that one did not work out. So actually I'll just delete those. Okay. Complex numbers, how to deal with it. I'm not sure. Yeah, I mean, I'm not sure what you actually want from me on that. Wait a minute. That's not week number 105. Have questions, ask. Oh, yeah, okay. Yeah, week number 134. Let me just see. Make sure I get this question from there. And we do have some questions. Again, I'm going to close this down. Once I do this, I'm going to close on the link. So if you guys do have a question, please make sure you guys do go to the link because I am going to take that down. So therefore, I don't get anything more. What's a math can't you enjoy talking about? I mean, a lot of math. Obviously, that's what I kind of do. So, but I would say, I don't know. I lot of like trigonometric identities. For some reason, that has always been one where it's like when I'm teaching that, I always just kind of like it a lot. And I think it's just kind of I think it's just the kind of like the strategy behind doing them is one thing that I really like a lot. So, all right, there is last week's live stream. So again, if you are interested in getting free tutoring with myself, then go ahead and check out that link and just go ahead and post a comment. And while I will go ahead and get this set up, and that actually would be perfect because then I can just go ahead and then I'll go ahead and switch over my thing. What am I trying to do? There we go. I just got to remember. Everything got switched up now that I had my comment picker. Okay. All right. So again, please make sure you guys are going from there. All right. So you guys ready? All right. I'm going to take this down. Please make sure bradmcclogan.com if you guys have questions. Otherwise, let's go ahead and go into there. All right. So this is in last week's live stream, week number 134. Okay. Post a comment, post any comment, and you can win. You guys ready? You're ready? Let's do it. Anything goes. Yep. Comment whatever else you guys got. Let's go for it. 11 comments. So you only got like a 1 out of 11 chance. I think that's awesome. So hopefully if you're looking for some tutoring, that is amazing. Because it's just not a lot. And this is Arcelia. Hopefully I got anything right. Well, anyways, what videos do you recommend we start on? I'm not sure what videos you talk about, but if you want to go ahead and join me for a 30-minute free tutoring session, I will be more than happy to be able to help you out. So what I'm going to do is I will make sure that I respond back to your comment, and I'll make sure I reach your comment. But if you are watching this live stream, you guys, or if you are end up being a winner, you can always go to my Discord, or reach out to me, DM me at Brian McLogan on Instagram. All right, so let's get that out of the way. Let's bring this up to enter full screen. Why are these not showing up? Oh, because I switched those around. It's crazy. Okay. Yeah, I forgot for the last couple weeks I did them there. That's crazy. All right, so we got week number 135 now. Okay. Week number 135. Cool. Uh-oh. There you go. All right, let's go and see what questions you guys brought to me. Hopefully it was all just easy fluff questions, and I will take it from there. Well, hey, Justin, good to have you on. And no, you're not too late. We're just getting into a little math portion. Do you do the SAT? I did do the SAT. I do not remember what I got, though, unfortunately. I will, not to skate around, I know I did not do very well. Like, not like horrible, but I didn't do... wasn't like a way high grades or anything like that, but I really have no idea what my grade was. All right, let's go ahead and I always got to go to individual. Switch this over. Sir, is math a good subject to take at high school? Yes, I would say that math is a great subject to take in high school. So good question. I haven't had this, a lot, but actually, so when I was a math major, so I became I was a math major, and I was trying to figure out like all the other things I wanted to do, like what else could I do? And so first I was like, oh, well, I'll do physics, right? Math, physics kind of makes sense. And then I realized that's a lot of math and a lot of applied math. And then I also figured out that I do not actually like a lot of applied math. Like I like more of the pure mathematics. So I ended up like not liking physics at all, actually hating physics. So I quickly dropped physics as my minor and realized that was not my career path. Then I was like, let's go and pick something really easy. So I thought communications was going to be something, kind of easy to go through. And also I thought it'd be good, to be a teacher, like, you have to communicate, right? So that's going to be kind of like in my alley. And I did I remember doing the, I had speech class and everything like that. Like that was all good, and there was really nothing else that excited me about the communications. Everything else I really just kind of disliked a lot. So then I realized communications was not going to be my major. And then I went into psychology, which would have been a good major. I actually did like a lot about psychology. I liked a lot of those classes, and I thought but I think also kind of again, getting deep into the weeds with psychology was just, I think it was just too scientific, not scientific, but too, what's the thing? Theory based, it's just all this kind of, even though I liked a lot of it, I liked more of the kind of real application stuff. And then I don't know how I came across political science, but I remember I was like, oh, maybe I'll test out political science. And I had no history of political or anything like that. And then I remember I just took a couple classes, and I absolutely just fell in love with, and it was really just kind of more small government, not the bigger things, but I just love learning the history of politics and how governments are set up all around the world. And it was just really, really interesting to me. And so I fell up. So actually I have a minor in political science. So interesting question. I don't not a lot of people know about that. All right. Well, set it up to Brian. I haven't done set theory in a while. I failed algebra last year. That's okay. You're all right. And taking the same class with the same teacher. Any mental advice? That's a good one. I had that happen a couple times. And I think I think you just got to be, real with the teacher. Hopefully your teacher is, good sport about it as well. Like, I'm not sure the dynamics of that. But I think the teacher, it takes a lot, to fail a class with the teacher and then to show back up. Right. But I feel like the circumstances when I had that happen, I was there to make the, student be successful. I never held anything against them for whatever reason. They, we might've had bad blood, which I don't think we ever did, or anything like that. But yeah, I think it's one of those things where you're like, hey, I'm gonna be successful, and and making sure you're letting the teacher know like that's what you want to do, and like how they can be able to help you achieve that. But yeah, I know it's tough. So definitely kudos to you for having to go back through and go through it. But yeah, I think a lot of times we just need a little extra time to be successful, and especially with math. So it's okay. Give yourself that time and then put in the work, and I think you're going to be okay. Yeah, I definitely wasn't interested in math at the time. I did not study. Like, I remember, like a lot of you guys go through like the math books and, courses and stuff. Like, I did not do any prep work for ACT, SAT. I think, I'm not sure if I got accepted into college. I just really didn't care much, to be honest with you. It was just not a very, I don't know. I just not a lot was on stake for me at that point in time. Like, I was just not in a kind of a different world of my own. So I just kind of winged it. I remember just showing up for an SAT and ACT and going from there. That was just, I don't know, kind of the student I was at that time. So yeah, I mean, I did okay, but I didn't do great at all. And I think even for one of the universities, one of the reasons they didn't accept me was because, yeah, I didn't have a high enough ACT score. And I don't remember the SAT, but yeah, it's, I know I didn't practice at all or do any prep work, which I probably should have. But I think by that time I got in to Western Michigan where I wanted to go anyway. So once I had that, I'm like, why, I think I was just going to try it once. If I didn't do well, then I'd like retake it and study, but like once I did it and I got accepted in my college, I was like, oh, I'm good. But yes, that's exactly right. Practice problems. Yeah, I mean, I answer mostly math-based questions, and then yeah, I mean, obviously, any questions you guys have in your chat. Applied math was something I was going with a minor in physics. Now, awesome, and 4 years in civil. Oh, awesome, congrats to you. Yeah, engineering was also another one where I was like, I don't know, there was just too much math applied for me. It just didn't mend well with me. I have calculus final on Thursday. Awesome, congratulations. It's my first time taking a final for college. Any suggestions on studying tips? Yeah, I mean, when you have something on Thursday, I would just go back through your tests and your quizzes and just kind of review all the stuff you did right, all the stuff you did wrong, right? I mean, I think the best advice I can give you in the last 4 days is, start now, start going through like, unit 1, unit 2, today, do tomorrow, unit 3, unit 4, right? And just going through those test quizzes, going back over through your notes, maybe doing some practice problems on problems you got wrong before and try to redoing them to get them correct. I would try not to be like too stressed out and too much pressure when you're taking your test. I know, easier said than done, but yeah, just kind of go through as much stuff as you possibly can. Put in obviously some practice work. Hopefully you have like a review or some practice problems you can, try to stay fresh on as well. And yeah, like I think it's better to put on a lot more work today and tomorrow and Tuesday and then just kind of like Wednesday, try to do a nice little slow review. All right. Well, I'll definitely have some information on pre-calculating coming up, but tonight, or at least tonight, I do not have. Yeah, I would have no reason not to believe. All right, let's go and get in. Let's see my questions. Please help. I think I only got like a couple questions for tonight. I'm actually really tired. Hey, what's up, Ben and Elliot? Good to have you guys on. Well, thank you for joining in on my stream. I appreciate it, guys. All right. That is a crazy. I would need to go ahead and take a look at that problem. That's actually and Noah, good to have you on, Noah. Thank you. All right. Let's can you recommend me a playlist for problem solving? I'm not sure what problem solving you're referring to, or if you have any like specific problems, let me know. All right. Let's go and see. Next problem, because I'm not sure if that one. Okay, all right, we can go ahead and simplify this. Let's go ahead and check this one out. So got at least one math problem. We'll go ahead and give a shot to. All right. And all right, let's see if we got any other questions from in there. The other form of fill was mistake. So, all right, so for A and B, I'll try to give us that. Oh, you should have had it for the last one. I'm not sure. Oh, equals 3. Equals 3a times x equals b. Okay, I'll give this one a shot. I'm not sure. Equals 3a times x to the b. Oh, okay. What is the equal? Okay, so you're trying to find 3a x to the b. Okay. I think. I usually like to review all my questions, but I guess I'll give this one a shot. Well, thank you. You're so very welcome. I'm so happy to be able to help you out with that. And can you explain what negative 16 means in terms of quadratic equation when falling down? I'm not sure what you mean. If you want to put that into context, I'm more happy to explain from on there. Was yours the one like the multiple composition, like a function inside of a function inside of a function? If not, I would probably need to go ahead and take a look at that one. I probably need more. Oh, no, here's your question. Let me go and see. There's one question. Yeah, multiple compositions. All right, find the 6 solutions. Inverse tangent of x. I'd have to go back and look through. Like, I'd have to spend time going back through them. That was not something I'm just like immediately up there. So I don't want to spend the time like on the live stream, like going over all of that from on there. So in that regard, I apologize. I do see your question, but I would just have to, I'd have to spend a little bit more time like looking over exactly from there to go over that question. So apologize for that. That's not something I'll probably be able to do, at least on the stream. But I'll maybe go ahead and take a look at it, and maybe I might be able to get through on the last stream, just kind of look. I just need to go back through and just kind of review exactly some stuff that you're looking for on that. But the inverse of with the x, oh yeah, so you'd have the 1 over x, inverse tangent of x, find the 6 solutions. But then you got to solve for those solutions. Yeah, looks like a doozy question that I would have to spend a little more time for. What is your opinion on self-study? I think it's all relative. To what you need your self-study to be on, right? I think for a lot of students, as far as like for math self-study, that if you feel like you are capable of like handling the content and being able to be consistent, then go for it. Like, I think I could never do self-study. I would never be disciplined enough to be able to, like, I can be very disciplined on a lot of things, but I think for studying, especially for math, that is not something I'd be disciplined enough to be able to do. But I know a lot of students, they can definitely go through it and they feel like they have a good foundation that they don't want to, a lot of times I think being in school, they feel like they are kind of held back. Right. So, or they're not able to kind of proceed at their pace that they want to go. So in that regard, like, yeah, definitely go for it. I think one of the things that kind of that I get a little bit worried about is when students, want to go for a self-study, but they either struggle with math or, they don't have a great foundation, or they feel like they need to go faster than they really do. And that's usually where that's usually where they kind of come into some troubles, because then really that's where a teacher or kind of a guide is really going to be able to help them out with that. That's right. You're very welcome. I'm happy to be able to help you out. Slugger Spirit, I just want to say you've been a massive help through high school. I love your content. Well, thank you so much. I'm happy to help. Awesome. Well, thank you guys. All right, so let's go and take a look at this question, and then I'll go 4 on there. And then, because I just wanted to go through 6 times, I forget, I should know. Okay, so let's go and take a look at this question and kind of see what exactly is going to be our power for our A and our B. All right, so the first thing that I recognize here is I have the 6x raised to the negative third raised to the third power. So using the power to product rule, what I can do here, just make sure, okay. What I can do here is the power to product rule is I can go ahead and distribute this 3. Come on, why is it not writing? Oh, let me get rid of that. Okay, I can go ahead and distribute the 3 to the 6 as well as the 3 to the negative 3. So therefore, what I can do is I can rewrite this as a 72x to the 2/3, okay? And that's gonna be over a 6 to the 3rd power, and that's gonna be an x to the negative 3rd, right? And then that's gonna be raised to the 3rd power, okay? So again, since it's separated by multiplication, you can do that. I should know 6 to the 3rd power, but my brain's already kind of shut off, so 216, that would have been right. Okay, and then I'll have, so now let's go ahead and simplify this. So I'll just go to the right here. So I have a 72x to the 2/3, okay? Therefore, that's gonna be a 216, and that's x to the negative 9th power. Okay, now, what do we know about when we have a variable to the negative power is we can rewrite that as the reciprocal, right? So if I had like x to the negative n power, I can rewrite that as a 1 over x to the n. And the same thing works here. If I have 1 over x to the negative nth power, I can rewrite that as x to the n over 1. You can just rewrite that as the reciprocal. Now, as far as over here, what I want to do is be able to see, well, how can I simplify like 72 over 216? And I believe a 36 is going to go into what, 6 times, right? And 32 divided by a 216. So that'd be a 26, a 1/3, I believe. Let me just double check. So this would be 72 divided by 216. Yeah, 1/3. Okay. So I can divide a 36 on the top and bottom, right? And that's what I did. So divide a 36 on the top and bottom. Actually, let's just do this on the next row. Okay, so when simplifying this, I can reduce this down to a 1/3. That's going to be x to the 2/3, and then this is going to be x to the positive 9th. Okay, so this is actually all over here. Now, the question is saying, can I rewrite this as 3 to the a, x to the b? All right, now, a couple things that we need to do. First of all, we need to get this 3 up in the numerator. So this is being raised to 3 to the 1st power. So if I want to put this in the numerator, then I just need to negate it. So therefore, this is going to be 3 to the negative 1st power. And then remember, when you're multiplying exponents, what do? You're going to add the powers. So this is going to be x to the 2/3 plus 9. Well, how do you add a fraction to a whole number? You just change the whole number to a fraction. Now we just need to get a common denominator. So I'm going to multiply by a 3 over a 3. All right. So then now I'm going to have a 3 to the negative 1. And therefore, let's see, this is going to be a x to the, a 2 plus 27 over 3. And 2 plus 27 is going to be 29. So I have a final answer now of 3 to the negative 1st power, and then x to the 29th over 3. And there we go. Voila. So in this example, my a is equal to a negative 1, and b is going to be a 29 over 3. Sure. All right, let's go and see. So if you guys have any more questions, I will be more than happy to go through. I'll try to see if you guys want to go to brianmclogan.com/Q&A. You guys can post your question inside there. Let me go and look. I'll look back at your question. I'm just trying to recall. I would need that X. What is this? Andrew, I watched your video on not having to memorize the inner circle by only understanding the first quadrant, but it was a bit fast paced, and I was wondering if you could explain it with, again, an example. Sure. Let's go and explain. Let's go and talk about that. So the main thing I wanted from that video for you to take away is, like, I always tell students, like, you need to understand this. You have to understand the first quadrant. Okay. So here's a nice little unit circle, right? And we know that we have our 45-degree angle, right? We have our 30-degree, or pi over 6. And then we have our 60-degree angle, or pi over 3, right? And then hopefully you guys there's a little trick, like the little hand trick or whatever may be the case for all these angles. Okay, and let's see, we're going to have, so we can just kind of do this. Just a matter of like every single student that's in taking trig or pre-calculus needs to know how to create that, right? So, what did I do? So we have everything divided by 2, 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 divided by 2. Not these divided by 2. What was I doing? And yeah, this was like square root of 1, square root of 2. No, yeah, that was going through that. So that's 1, right, comma 0, and that's 0, comma 1. All right, and then basically what we do here is now going to be the, that was square root of 3, square root of 2, square root of 1, and that's square root of 3, right? Yep, square root of 2, and then square root of 1, right? So it's basically just going to be 1/2, right? So we don't need to really have the square roots there, so we can get rid of them. Okay, so these are going to be angles. So that's for pi over 6. This angle is for pi over 4. And this angle is pi over 3. Okay, and obviously we'll do pi halves, but let's just keep things simple. Okay, so the main thing I just want you to understand here is this is the first quadrant. So if we're going to take this on a coordinate grid, all right, then this is going to be the y-axis, and this is going to be the x-axis, right? So the main thing I want you to understand is everything that's in this first quadrant, okay, is going to be, get rid of the comment, is going to be positive, positive, right? And notice like all these coordinate points are both positive, 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 okay? However, if we go in the second quadrant, what are we going to get? We're going to get a negative, positive, right? In the third quadrant, now we're dealing with a negative, comma, negative. I don't know why I have a 1 there, so I'll just go and get rid of that. And then down in this fourth quadrant, right, now we have a positive and a negative, right? So what you're basically doing is you are basically just understanding that like everything that's in the first quadrant is just reflected about the x and the y-axis. So the coordinate points are going to be exactly the same. The only difference is they're going to be positive and negative. Now, the other thing that I want to take away, so that's one part. That's like part number 1. You got to understand the quadrants make a difference. I actually kind of like this part 1. So part 1 is the first quadrant. Part 2 is the quadrants, is the positive, negative. I'm going to probably make another video of this. So that's why I'm writing this down. And part 3 is going to be the reference angles. Okay, so now you got to understand reference angles. So what I want you to understand is whenever something is pi over 6 away from, like, here's the x-axis, right? Whenever you have a line that is, or an angle that is pi over 6 away, like let's pretend these are all pi over 6 away, okay? They're all going to share the coordinate point. They're all going to have the same coordinate point, right? They're both going to be square root of 3 over 2, comma 1/2. This would be negative square root of 3 over 2/2. This would be negative square root of 3 divided by 2 and negative 1/2. This would be positive square root of 3 over 2, comma negative 1/2, right? So if they have a term, if they have a reference angle that, I'm sorry, if you have an angle that is like, has the same reference angle, like, let me do an example here. Let's say I have an angle of, I don't know, let's do 7 pi over 6. Okay, 7 pi over 6 is going to be over here. So the main thing I want you to understand is 7 pi over 6 has a reference angle, right? So let's call this theta. Then theta prime, which is the reference angle, is pi over 6, right? This is pi over 6 away. This angle is 7 pi over 6, right? But the reference angle is pi over 6. Well, that's important because if we know what the reference angle is, then we know this angle is going to tell you the coordinate point. So what you have to do is find the reference angle, which is the acute angle between the terminal side and the x-axis. So if you can identify what the reference angle is, that's going to tell you what the coordinate is. Then you just need to know what the angle is, which quadrant it's in, right? So therefore I recognize, okay, so first of all, we know that the reference angle is pi over 6. Therefore I know the coordinate point is square root of 3 over 2, comma 1/2, right? So I can say, all right, it's square root of 3 over 2 comma 1/2. How did I know that? Because I know what the reference angle is. So once you know the reference angle, you know the coordinate points. Now I need to know, well, what quadrant is it in, right? And we know that halfway around a circle is pi, right? That's pi, which is the same thing as 6 pi over 6. So if I have 7 pi over 6, then you're just going to go an extra section, right? You're just going to go an extra section over. Therefore, it's in the third quadrant. Therefore, both terms are negative. So I'm not sure if that was helpful. I know that's basically what I kind of went through in the video. It was much more a little bit long-winded. This was much more to the point, or much more like kind of a summary. So I'm not sure if that was more helpful for you or less helpful, but feel free to answer any follow-up questions. I'm glad to tell you that I just watch your videos. Well, awesome. So happy to help you out. All right. Another kind of like follow-up question. So how do you convert from radians to degrees, right? So one thing I just talked about is we are just talking about radians and degrees, right? So in this case, what I have here is that is, actually it's, okay. I don't want to get through much. How would you graph? A graphing question. All right, Velocity. I might take you up on that. So one thing I talked about is halfway around circle is going to be pi. All right. So that's what pi is. Pi is basically halfway, the measure of a distance halfway around the circle. Now, that's also, if you think about that, that's also equal to 180 degrees. Okay. And it's just kind of the same thing that I want you to think about is like 12 inches is the same thing as 1 foot, right? Completely different measurements. Not really completely different measurements. But yeah, they're different units, right? But they represent the same thing. 12 inches, same thing as 1 foot. Pi, which is in radians, right, is the same measurement as 180 degrees. Just different units, same measurement. Okay. So if we want to be able to convert between the two, what we can do is use what we call this ratio. So for instance, if I said I had 60 inches, right? I said, hey, 60 inches, how many feet is that? Well, what would you do? What you would do is you'd multiply by the conversion ratio. And you'd say, all right, 1 foot is equal to 12 inches, right? And so then what you have here is now when you multiply 60 inches times 1 over 12, what happens? The inches divide out, right? 12 goes into 60 5 times, and you're left with 5 feet, which is the correct answer. So what if I had the same thing? What if I say it's 60 degrees? And I said, hey, how many radians is that? Well, what you're going to do is you're going to multiply by pi over 180. So watch, if I multiply by pi over 180 degrees, what's going to happen? The degrees are going to divide out, right? And then 60 over 180 is 1/3, right? So that equals a 1 pi over 3, right? Which is the same thing as pi over 3. And that's right. It's 1/3 pi, or pi or thirds. So the same thing is if I had like, 80 inches and I want to know how many feet that is, if I had like 10 feet and I want to know how many inches that would be, same thing. It just works it works the exact same way, guys. Like what if I said, I have 10 feet, right? How many inches is that? Well, what you're going to do is you're not going to multiply by 1 over 12. You're going to multiply now by 12 inches over 1 foot, right? Because now you want the feet to divide out, right? So feet divide out and you're left with, that's 120 inches. And the same thing with things that works over here. What if I had pi over 4, right? And I say, hey, what degrees is that? What degrees is pi? Or let's do a 5 pi over 4. Like how many degrees is 5 pi over 4? What do you do there? Well, you're not going to multiply by pi over 180, right? You want to get rid of the pi. So I'm going to multiply by 180 degrees over pi. Now what's dividing out, right? The pi's are going to divide out. Then I have 5 divided by 180, or 4 divides into 180. That's 90, right? So you have 5 times 90 degrees. And that's going to be wait a minute. What did I do? That's 45 degrees. I knew something was wrong. That's not 90. That is going to be 45 degrees. And that equals 135 degrees. Okay. All right. So I'll try to do velocity. I'll try to see if I can do a question for you on that. All right. So it says why. Come on. y equals a negative 1/2 times sine of 3x. And then we're going to graph between negative 2 pi over 3 and pi over 3. Okay. Okay. I'll go ahead and give it a shot. Well, hey, said Napoleon. Is that popping up? There you go. Oh, right one. Okay, I was wondering if the upcoming video of this, you could maybe cover how to get the coordinate points of what you mean, and also how to get the radians. I mean, I have videos, a ton of videos on that if you want to go and check it out. But yeah, I can definitely go ahead and, if you want to submit the question, for next week, I can definitely spend some time going over it as well. And hey, said Napoleon. Just Kurosawa, hey Brian, I was wondering why the points in the third quadrant and fourth quadrant have odd symmetry, or points across the y-axis have odd symmetry in general. Why the points in the third? Yeah, I mean that's basically kind of like their definition is they have that's their reflection about the origin from on there, and that's why the you can think about the tangent and the tangent and sine are going to be your odd functions in that regard. I'm wondering why the points in the third quadrant. Fourth quadrant. No, they don't. No, third and fourth quadrant don't have odd symmetry. They reflect about the y-axis. I think you might actually be mixing some things up regarding that. But I can definitely talk more about that if you have more general questions there. And all right, I can maybe do this problem, another logarithm problem. Why not? Why don't we just give it a shot? So this problem is ln of x minus 2 equals a 3, not equals, minus a ln of 2, or sorry, 3, ln of 2 equals 2. All right, I'll give it a shot. I'll see what you guys got. Pythagorean theorem. Pythagoras theorem is awesome. Good job. Hey, Logan. Thanks, man. Good to have you on. My question is, there is any direct formula to factorize cubic polynomial? There is. There's the cubic formula if you want to follow it, but I don't use it, and I don't think it's very worthy unless you're like going to be applying it that you need it. So, all right, let's go through these two questions, and then I think that should be enough math for me tonight. So in this one, we have y equals negative 1/2 sine of 3x. So whenever we're graphing a trigonometric function, there's a couple of like things that I like to kind of do. I'm not going to worry about this restriction here in a second. What I want to do is just kind of like lay out the piece of information that we need to know. So first of all, we need to know what the sine graph looks like. Okay. So we want to know what the parent graph is going to look like, because what's basically going to happen is we're going to have some transformations. All right. So there is going to be y equals a sine of x. All right. Now that has a period of what we call 0 to 2 pi. Like that's how long it takes the graph to repeat itself. The graph also has an amplitude of 1, because that's basically how high and low the graph are going to go. All right. So let's go and see everything that we have here. So when I have a negative, that is going to be a reflection about the y-axis, right? So I'm sorry, reflection about the x-axis. So whenever there's negative on the outside, so I'm just going to write that. So we're going to say reflect the x-axis. Okay. The 1/2 is going to be the amplitude. So I'm going to say the amplitude is going to equal 1/2. So what that's going to do, because that's the absolute value of A. So now the graph is only going to go up as 1/2 and down to 1/2. And then the only other transformation we have is going to be this 3x. So my period, which originally was 2 pi, is now actually being horizontally compressed by a factor of 3. So to understand what that be, the period here is going to be, when we want to find out the period of a function, we just take, this actually is going to work out pretty good. So whenever we want to find the period of a function, that is going to be, you just take 2 pi and then divide it by b. And you might say, well, where's b? Well, in this function here, your trigonometric equation is y equals a times sine of bx plus d. Okay, so there's kind of a, actually, I'll put the c in there just so you know it's there. Minus c plus d. Okay, so we don't have a c, right? There's no plus or minus here. So and we don't have a d either. But you can see b is going to be what's in front of your x, which in this case is going to be a 3. So in this case, we have a 2 pi over 3. Okay, so now this graph is going to go all the way over to a 2 pi over 3. Now, we kind of have something kind of nice, though, is, oh, we actually got to do our X scale. So the other thing I like to do is create what we call an X scale. So the X scale is like, notice how I didn't create any like tick marks here. This is kind of like my lazy graphing, but technically like we have some kind of important points that are going on. We have the maximum, we have the minimum, and we have these two X intercepts that are going on here. So these are going to occur at pi. This would be pi halves, and this would be a 3 pi halves. All right, so to find the X scale, basically what we're going to do is notice how I broke up the period and I divided it into 4 parts. So to find the X scale, all I'm going to do is going to take the period and divide it by 4. So take the period and divide it by 4. So in this case, what I'm going to do is a 2 pi divided by 3 divided by 4, right? So then if I multiply by the reciprocal on the top and bottom, then I'm going to have the period now is going to be a, let's see, that's a 2 pi over 12, which can be simplified to a pi over a 6. All right, cool. So what are we going to do with this information? So what we're going to do for this information is I'm going to scale this for what I need, because the student wanted me to graph this on the interval of negative 2 pi over 3. So if I take my graph, okay, now rather than going from, so rather than starting at, or going at pi halves, now what I'm going to do is go by pi over 6, right? So my first one's going to be pi over 6, right? And then 2 pi over 6. Okay, now 2 pi over 6 is what? That's pi over 3, right? Wouldn't you agree that just simplifies to pi over 3? So cool, I got something. So the next thing is, though, it also says to go negative direction, negative 2 pi over 3. So what I'm going to do is actually go farther in this direction. So the cool thing about the sine graph is this, like that's what we call the initial period, which I did up here. But remember, the graph continues indefinitely to the right as well as to the left. So I can do this exact same scaling system in the other direction. So I could say negative pi over 6 and negative 2 pi over 6. This would be a negative 3 pi over 6. And this would be a negative 4 pi over 6. Okay, so now what we need to do, though, is understand this graph got shifted, right? So let's just do, I'm just going to change the scaling. I'm going to be lazy, not really be lazy, but I'm just going to say, all right, now the graph is going to go only up to 1/2 and down to negative 1/2. That's the amplitude. It's being compressed. But rather than going up, I'm now going to go down, right? Because this, if you kind of look at this graph and reflect about the x-axis, you can basically see that like now the maximum is going to go down, right? So now I'm going to go down and then I'm going to go up. So to the right, the graph's going to look like this. And you can kind of see like what I'm doing is reflecting this area across the x-axis. Then I'm going to go up and then down. I'm just following the patterns here and up. So this graph is going to look something like this. And again, I don't want to get in the way of the, there you go. So, and then this is going to be your negative 4 pi over 6. And again, I'm not simplifying that just for reasons, but hopefully you can see that that does follow within on the scale. Jessica, can you explain even odd symmetry using the unit circle? I thought that the points in the third quadrant and the fourth quadrant have an odd symmetry as the points are reflected across the y-axis. No. So odd symmetry is when things are reflected about the x and the y-axis, also called the origin. So, so if something is even, so let's just kind of go through symmetry here real quick. So even symmetry is when something is reflected about the y-axis. Okay, so whenever you have something that's reflected about the y-axis, that is going to be even. So the most famous one here, okay, the most famous is going to be like the quadratic. And again, the way you can look at it is if like if I say, let's say 2, right? And then let's say this is 4. And then if I say negative 2, you're going to have the same point, right? They both have the same point. They're reflected about the y-axis. That's even symmetry. And then if we want to talk about like odd symmetry is reflected about the x and the y-axis. So the famous one that I like to use here is like the cubic function. Okay, and I don't know, let's just go again to 2. So if I said 2, right, this point is going to be what? An 8, right? But if I say negative 2, then this point would be down what? A negative 8, right? So the way that the symmetry kind of works, if you want to think about this algebraic representation, the f of x, let me do this. If you have even symmetry, then let's say f of x is going to equal, well, actually I can just go through this. Let's do it this way. then f of negative x is equal to f of x, right? And don't you agree? Like 2 and negative 2 both have the same answer, 4. If it has odd symmetry, then f of negative x is equal to the opposite of f of x. And again, that works, right? 2 gives you 8. Negative 2 gives you negative 8. So hopefully you kind of see how that works. Algebra at the age of 14? Yeah, for sure. But I definitely go and speak with your parents, teacher, post-teachers to make sure that's the right decision for you. How can you get to stretching factor within an equation? I mean, typically the vertical stretching is going to be when you're multiplying by a scalar. I'm not sure exactly what you're asking, but this graph was actually horizontally compressed because it was multiplied by 1/2, right? If it was multiplied by a whole number, then it'd be vertically stretched. Obviously, when you have stretching and when you multiply by a number inside of a function, that's going to be your horizontal stretching compression. I'm not sure if that's what you're asking, but hopefully that was helpful. All right. So in this example, first thing I would do is let's go ahead and simplify this using the rules of logarithms. So the first thing I would do is I would bring this 3 up here and write it as a power. So therefore I'd have an ln of x minus 2 minus a ln of a 2 raised to the third power. Now I can simplify that. 2 raised to the third power is 2 times 2 times 2, which is going to be 8. That's equal to 2, right? So therefore I have an ln of x minus 2 minus a ln of 8 equals to 2. Okay. Now I notice I have the difference of two logarithms, so I can rewrite the difference of two logarithms as the quotient, right? So I can say ln of x minus 2 all over 8 equals a 2. Okay, now I need to get rid of the ln. So to get rid of the ln, basically what I need to do is exponentiate on both sides. And the cool thing about logarithms, in the rules of logarithms, if I have b raised to the log of b, right, equals of x, then that's just going to equal x. So remember, natural logarithms have a base e. So if I want to get rid of this natural logarithm, I just need to exponentiate with base e on both sides. So in doing that, I get a x minus 2 all over 8 is equal to a e squared. Now to go ahead and solve, I'll just multiply by an 8 on both sides. And x minus 2 is equal to an 8 e to the second power. And then just add a 2 both on sides. So 2 equals a 8e squared plus 2. And then obviously you can just use a graphing calculator to be able to evaluate from there. So typically, let's see. So typically I would say that pre-calculus is going to be more difficult than calculus, and not so much from a curriculum standpoint, but the reason why I base that on is like kind of for students have to get used to doing upper level math class and doing more rigorous math. A lot of times students can be very successful in math up to pre-calculus with doing very little studying, with actually applying themselves very much. And so once they get into pre-calculus, they realize, oh crap, I got to put in like a lot of work. I actually have to study. I actually have to, correct my mistakes and do everything like that. And there's a learning curve, I think. You are going to be dealing with more difficult problems, more advanced problems. You're going to be getting more in-depth, work. And so students have to learn how to study. They have to learn how to problem solve differently. But I think once students are able to go over that learning curve and that stretch, then calculus is much more of a breeze. However, I think for some students, maybe if they're not challenged in pre-calculus, that's where that's where the calculus can be more of a challenge for them. But otherwise, at least from students that I have worked with, that usually the pre-calculus has been the bigger struggle than the calculus. Thank you so much. You are very welcome. And good Brandon, thanks for all your videos so far. You were very helpful, Chris. I'm assuming you had something. All right, Joe, can you reduce? Oh, for this. All right. All right, guys. Well, thank you so much for joining. I will be again with you guys next week for week number 136. Hope you guys have a great week, and only a couple more weeks for some of you, and some of you are going back to school tomorrow. So wish you guys all the best of luck. I will see you guys next week. Cheers.